Okay, now let's start with the first chapter. The first chapter is about fluid kinematics. Fluid kinematics is a science that focuses on studying the fluid flow without considering the forces. In other words, I am only concerned with the velocity of the fluid as it moves in the flow domain. The flow domain is the region in which the fluid flows. It could have many shapes as shown in the figures here, and it depends on the type of your problem. So first, we define the flow domain. The flow domain is the region in which the fluid flows. Inside the flow domain, I have a fluid. I have fluid particles. Each fluid particle has a velocity. So for example, in this flow domain, let's make the annotation here. In this flow domain, I have the the fluid flows as it's shown in the figure. The direction of the arrow refers to the direction of the fluid particle at this point. And the direction of that arrow refers to the direction of the fluid particle at this point, and so on. So inside the flow domain, I have a fluid, I have fluid particle. Each fluid particle at each location has a velocity. And the velocity is by definition a vector. So it has a magnitude and a direction. For example, in this flow domain, this is the flow domain near the wall. For example, you have a solid wall and there is a fluid flowing near to that wall. So this is how the velocity vectors look like in this domain. For example, I have a fluid particle at this point moving in that direction, and the length of the arrow is proportional to the value, to the magnitude of the velocity at this point. For example, another example, at this point, I have a fluid particle moving in this direction, and the length of the arrow corresponds to the velocity magnitude. So, in summary, when I say a velocity field, that means that I want to define the velocity in terms of its magnitude and its direction at each point in the flow domain. At each point in the flow domain, whatever the shape of the flow domain is. And we should ascertain the idea that velocity is a vector, that it has magnitude and it has direction. So this is the first concept. We learned now what is meant by the flow domain and what is meant by the velocity field. This is the first concept. And on the velocity field, there are a lot of concepts that are built, as we will see later. Okay. The second thing, we showed that the velocity is a vector. So it has components. For example, if I am considering the Cartesian coordinate system, So the velocity will have a component in the x direction named u, a component in the y direction named v, a component in the z direction named w. And the components together form the velocity vector. But what is meant by this relation when we say that the velocity is a function of x, y, z, and t? This relation means that at each point in the flow domain, at each x, y, z, because we define the point in the flow domain by x, y, and z. At each x, y, and z, you have a velocity that could be different from the velocity at another x, y, z point. And from time to time, the velocity could also change. So for example, at this point, at certain x, y, z, the velocity has a value. And at the same point, after some time, the velocity could change. So in general, we say that the velocity is a function of the space coordinates x, y, z, and the time. Okay. There are some variations of this relation. The first one is what is meant by one-dimensional flow, two-dimensional flow, three-dimensional flow. When I say one-dimensional flow, this means that the velocity vector, is a function of only one of the space coordinates. Function of x only, a function of y only, a function of z only. When I say two-dimensional flow, this means that the velocity is a function of two of the space coordinates. It could be a function of x and y, it could be a function of x and z, it could be a function of y and z, and so on. And for a three-dimensional flow, the velocity will be function of the three space coordinates, x, y, and z. This is a point. The second point, what is meant by steady and unsteady flow? If the velocity vector is function of time beside the space coordinates, we say that the flow is unsteady. When the velocity vector doesn't depend on the time, then the flow is steady. So steady is when the time is absent from the equation of the velocity vector. Unsteady means that the velocity is a function of the time, and at the same point, if you observe the velocity at the same point, you will find that it changes from time to time.